sampling rate of CAN is 87.5%. What is the sampling rate? So sampling rate is number of signals changes per unit of time changes per unit of time. Okay, so generally it will be measured in the form of hertz, means that is a frequency. So like whenever you're transferring the data, right? So whatever the sampling data you are considering, so it will follow two methods. Okay, so you can write down hard synchronization and soft synchronization. Write down the other concept. Hard synchronization and soft synchronization means whenever you are transferring the data, right? So the data it's having some frequency. Okay, so means the accuracy will be there at 87.5%. Accuracy will be there. So this whatever the signals speed means that speed will be there, right? So that speed will be given as the sampling rate. Okay, so we cannot say the speed in real time. For our understanding, we need to say that speed. Okay, so the speed here is nothing but the frequency. Okay, so the frequency will be there. So whatever the sampling rates, it changes per time, like it will be the 2 seconds or 1 second. So that will be covered as the hedges, means that whatever the frequency units is hedge units. Okay, now whenever you are transferring the data, you start the data, you need to transfer. It always should sync with the clock because each and every node it have the clock. Okay, so independently it have the clock. It's not the dependent. As a CAN is a asynchronous protocol, as we know, means it is a independent of the clock. Okay, so what is happening is whenever this is a ECU of consider like ECU1, I'm connecting to the bus. This is a CAN bus. So for this CAN bus, when we connected with the multiple ECUs, right? This is a ECU2 and this will be the ECU3. So when we are connecting these multiple ECUs, right, independently, where the master, the lower identifier will get the higher priority for transferring of data. So now consider this ECU got the higher priority for transferring of the data. Now others becomes his slaves. So when you are transferring the data, all the nodes should receive the data at a same time. Okay, at a same time it should be received. Okay, how this syncing should happen means how the data will be happening at the same time. So that will follow the hard synchronization and soft synchronization. What is hard synchronization and soft synchronization? For transferring of the data from master to the slave end. So the first hard synchronization is everyone starting at the same exact time. Okay, hard synchronization is like everyone starting at the exact same time. This is a small point you need to write down for a better understanding. And soft synchronization is like adjusting to stay in the sync as you go along. Means it is kind of an adjustment. This is not like that. It should be sync at a time. Okay, at the exact time means if you say 10 seconds, it should go the 10 seconds. The message should be delivered in a 10 seconds. If you say soft synchronization, it will be like a just adjustment of 9 seconds, adjustment of 11 seconds between that time. Okay, this will be the hard and soft synchronization on top overview. Further, we'll understand in detail about hard synchronization and soft synchronization. Okay, so both will help for communication purpose only, nothing else. And hard synchronization. So hard synchronization, in a CAN network, all the devices like whatever the devices means ECUs, we call as a computers or the sensors, agree to start counting the time at the same time. Means whatever the ECUs that we are connecting on the bus network, right? So that it will say that you can send the data at 5 seconds or 4 seconds, like it will be defined. So based upon that only, so all the ECUs will be communicated, it should be communicated with 5 seconds or 4 seconds. So this is one definition. In a CAN network, all the devices like computers or sensors agree to start counting at the same moment. And this ensures that they are all on same page, means because whatever the nodes we have, right, it will be on a same page only, and send and receive the messages at the right time. This is just a point of understanding of the hot synchronization. Okay. So is it clear, right? Soft synchronization is just the mutual understanding to send the data at the same time. Okay. At same moment, at the right time. So that will be the differ. And what is the definition of this? So you can write down hot synchronization refers to the process, the process by which all nodes means our ECUs, all nodes on the network, on the network synchronize their synchronize their internal clock to the same time reference. This is a very important definition you need to give in interview, like for the hot synchronization means whatever we discuss, right, or in the network, all the ECUs should be synced together. Means if it is a master says that the slave 1, slave 2, slave 3 all should receive the data at 2 seconds of time, means the 2 seconds of time only the data should be transferred to the slaves. So whatever the master is sending. Or synchronization is refers to the process by which all nodes on the network synchronize their internal clock, means it is a independent clock, right? So whatever the clocks you are, it will be there for ECUs. If it is a 2 seconds, it will be a 3 seconds, it will be a 4 seconds. But whatever may be the independent time you set, when the master is sending the data, this all should set at a 2 seconds of time. That is the hard synchronization. Okay, is it clear on this concept? This synchronization is essential for the proper functioning of the CAN network, and it allows the nodes to accurate their time, the transmission and receiving. Whatever the transmitting or receiving of the data, you need to ensure that within the time the data is communicated. So that is the main purpose. Okay. And so what are the bits means whenever you are transferring the message, right? So the in we have the startup frame. Startup frame is it will transfer from 1 to 0 when the during dominant only the data will be transferred. So whenever it rises from falls from 1 to 0, right? So that will becomes as a part of a the transition. It's happening from falling means this will be kind of a falling, so recessive to dominant. So during that time only hard synchronization will happen. And moreover, the other field is intermission field, means the intermission field is between one message to another message there is a space. Okay, that will be the intermission field we usually say. So this is also for synchronization purpose, means once the recessive is ended, end of frame, it have all the recessives, right? So again from 1 to 0, so it will fall again, means it will be all the recessives will be there 7 months again. Whenever the other message need to start, so the message should come to 0, means during 0 the dominant, the message 2 will be started here, message 1, message 2, like you can able to see. So when means it is a 1 to 0 here, the dominant is there, it is sending the message again. When it is coming from 1 to 0, right, again another message is sending. So it is a resynchronization is happening. Synchronize means it is not breaking the communication of the signals, so just it will be syncing the messages and it is transferring. So like that it will be the hard synchronization will be followed. Okay, the very important definition of hard synchronization is this is a point you need to give it in interview. And next, coming to the soft synchronization. Soft synchronization is whatever the messages are we are transferring, right? It should be adjusted within the duration of time. Okay, so device adjusting the timing based on the message they receive from the other devices. Just it will do the small adjustment. Okay, whatever the time they defined. So write down soft synchronization. Soft synchronization refers to a method used by can node to align internal clock with the timing of the message on the bus. With the timing of the messages on the bus. With the timing of the messages on the bus. Soft synchronization refers to the method by a CAN node. CAN node means our ECU that is connected on the CAN. Thus we call as a CAN node. To align their internal clock with the timing timing of messages on the bus. Timing of the bus. Okay, so synchronization messages means whatever the soft synchronization, right? That is for resynchronization. This is for, it is also then like resynchronization means happening again and again. It is a syncing of the messages, just adjustment we need to do, right? So with the soft synchronization, whatever the messages that we are receiving or transmitting the messages, so it will keep on monitoring. Okay, the keep on monitoring, adjusting the timings. So that only it will do. And moreover, so it is also depends upon the CAN messages. So it will be the startup frame and intermission INTR field, we say. Intermission means inter field. Okay, so the main definition of the point of the soft synchronization is, this is the point you need to say. So it is just aligned with the internal clock with the timing of the message on the bus. And it will be the adjusting the time based upon the um, received or transmitting messages. You can write down these 2 points. And if you need another point, you can write down like align means align their internal clock means just adjusting the timing. Adjusting the timings based on the message they receive from the other devices. You can write down this point as well. It make you understand better on the soft synchronization definition. Is it clear? Next, further, one more topic, we'll go into CSMA CD. So most of them you saw in the assignment or the CSMA CD. What is this CSMA CD is? So it is a method. Okay, so whenever the nodes are connected, you are able to see there is a B, C, D, and we have a CAN bus connection. So means it need to sense, right? Like which is the A node that is requesting the data to send, or which is a ideal. There is no data is transferring on the bus, no data. So that should be a sensing. Okay, that will be the carrier sense. Multiple access means multiple ECUs, whatever the nodes we have, right? Or 2 at a time or 3 at a time need to access the same data. Whatever we discussed about soft synchronization or synchronization, when we are sending the data, right, at a time, there will be a chance of collision. Collision means the data cannot go to the another nodes. So because of the transferring from A and receiving of D at the same time, the same data, the collision can happen. That is a collision. So multiple access, carrier sense when the bus is ideal, and moreover, multiple access when the nodes are transmitting the same data, the collision can happen. Okay, so that time, once the collision is detected means you will get a jump, means that will be the traffic will be getting, because the data cannot move further. So to avoid this, in all, not only in CAN, we have Ethernet also, like FlexRay, and it have two things like wired and wireless. Okay. So what is the benefit of this is CSMA CA is generally used in wireless network. Okay. So remember, the wireless network is nothing but the Ethernet. Okay. So this is the Ethernet. Okay. So Ethernet is a protocol that we use for the CSMA CD method, CA method, and CSMA CD is generally we are using the wired network. So this is like a LEAN protocol or CAN protocol, and even Ethernet, because Ethernet is a wireless we have and wire also we have. So if we used wired, we can use in the Ethernet also, and we have a flex ray. All those will be comes under a part of the wired network. So what is the purpose of this? So whenever you are connecting the nodes to the multiple bus, there will be chances of the collision. You can write down CSMA CD. The topic is CSMA CD. CSMA CD generally used in wired network. CSMA CD is generally used in wired networks. You can write down parallelly CSMA CA is generally used in wireless network. Okay, for understanding both way of communication. And what is the purpose of this? When you are using wireless, right? So based upon the IP address, you send the data, right? So that time the collision, you cannot you cannot get the traffic, or you cannot get the collision. So that CSMA CA is, it will minimize the risk of collisions. Why we need to understand this? Because when to understand the CAN, any other protocol, so if you say there will be huge traffic all the time, how data will be transferred? Okay, so there will be sometimes the wireless will be there, so that may help us to avoid the collision. So it will minimize the reflection. Okay, so minimize the risk of collision. And CMA CA, it avoids the collision. It avoids the collision before they occur by sensing the channel. By sensing the channel, it will avoid it. That is a CSMA CA. And next, coming to the CSMA CD, it reduces the recovery time. It reduces the recovery time and detects the collision. This is all before, right? Before only it will do collision. After collision, it will detect. This CSMA CD, it detects collision after they occurs and stop transmission. So that is what we need to understand about this CSMA. This is a major difference, whatever this point and this point in the CSMA CD. So this will the CSMA CA, it will avoid the collision before they occurs. This will be after they occurs the collision, they will stop sending it. Means once the master will be there and slave is there. So if the collision is got, means it will stop sending the master. Master will stop sending the data. Okay. So that is the major difference of CSMA, CA, and CD. So now in detail, we need to understand what is a CA, what is a CSMA, CA. The full form of CSMA, CA is carrier sense multiple access. Write down carrier sense multiple access. That is a full form of CSMA. Carrier sense multiple access. And what is a CD is a collision detection. So we told, right? So after getting the collision, it will stop transferring. So that's what we need to understand the CSMA CD, because it is in a wired network, right? In the wire communication protocol, after once the traffic is got, it should avoid the traffic, because again it should send the messages. No, if keep on sending in, means it will be difficult to clear the traffic and it's difficult to send the messages. So that's what the CSMA CD will be followed, the method to avoid the traffic and to avoid the collision. So if collision occurs, it should be removed. Okay, so it employs a different access method, so that is known as a CSMA CA. So what is a CSMA CA? Is a protocol used in a computer network to regulate the access. So the definition of this CSMA, you can write down. CSMA is a protocol method protocol method used in a computer networking means what is the topology that we follow, like a linear bus, the communications with the ECUs. That will be computer networking to regulate the access. The very important point to regulate the access to shared communication medium. Regulate the access to a shared communication medium by having a device listening before transmitting. Means these are the master and slaves, right? So master will always send the data, slave should listen it. This master is talking and slaves are listening. It's kind of the communication it will have. Okay, so CSM, it is a method like same to regulate the access because all the slaves should get the access on the shared common medium. What is the shared common medium? It is a CAN bus. So the slaves are listening and master is slaving. And next will be the part of the carrier sensors. What is the carrier sensors is? So as I told you, the bus is say ideal. There is no data is sending, no message is sending. Okay, this should be sensors always. Before transmitting a data, a node listen to the bus to check if it is ideal or not. Because now this is a master and the slave it have. So whenever the master need to send the data, that time this should be a free. It should be ideal. No means it should be a free of data. There is a space should be required. So if it is ideal, then only the message will go to the slave. So this is about carrier sensors. Carrier sensors will always check that bus is a ideal or not. To check the bus is in ideal. You can write down this point. Before transmitting the data, a node listen to the bus to check if it is ideal, or you can write down to check that bus is in ideal or not. To check that will be the carrier sensors. So these are some knowledge purpose. So in interviews, very rarely they ask you, but you should aware on this concept. So if the traffic is occurred in the network, how you will resolve? Is there any method to follow? Like that, the questions they will ask you. Okay, but in real time, we cannot use this. But means what when we are working in the industrial channel, we are not able to see this traffic, how this is happening and occurring. But in vehicles, you usually get this kind of if there are not syncing is happening properly. So vehicle level, they will do. We're able to monitor this system, and during development phase also it can be verified. So if bus is busy, another node is transmitting, it wait until free. Means if, as I told you, right, like previously, if one message is transmitting, if again we need to send the another message, it should wait. And coming to the multiple access, so once the node determines that bus is ideal, it proceed to transmit the messages. Means multiple access means any other messages also, masters also will take the responsibility as the CAN. Generally this is a term like whoever the master have a responsibility of transmitting data continuously. If bus is ideal, right, so then it will be transferred. So in the CAN protocol, which have the lower identifier, will take the higher priority for transferring of the data. And collision avoidance, CA, so CAN doesn't employ collision detection like Ethernet. Okay, so instead it have a priority based arbitration, right? We have a so to avoid the collision, right, so it will follow the lower identifier, will take the higher priority, so then only the data will be transferred, so it will avoid the collision. And collision detection, so whenever the collision is happen, right, because of um, the transferring of the data at the same time, and the jam is created, so at that time it will be detected, and it will stop sending the messages, and again it will do the retransmission. So these are the terms and keywords of the CSMA and CS, multiple access MA and CA and CD. Okay, so how this will work in a CAN protocol? So I have data that should be transferred on the bus. Okay, so when it is free only, the data will be transferred to the ECU. So it will follow these three methods: CA, CD, CR. So CR is the carrier resolution, means what is the sampling data that we need to send it on the bus. So what the CA will do, so it will prevent the collision from occurring among its frames. Okay, so it will avoid the data, means what, whenever you are transferring the message, right? So the data, it will be avoided. You can write down the collision avoidance, CA. It prevent the collision from occurring among its frames. Prevent collision from occurring among its frames, CA. And coming to CD, collision detection. If collision occurs between the frame, it is identified. It is identified and appropriate action is taken. Means proper action will be taken. Proper action will be taken. Next, collision resolution. If collision happens between the frame, it is resolved in that instant only successfully. Whenever the collision is happened, right, it will be resolved at the same time. That will be the CR, collision resolution. Okay, is it clear? This is all about CSMA CA. You are getting right. So generally, we'll get the collision. The traffic will be created. Then it follow the collision detection, the CSMA CD method. So then it will be identified and it will take the action. Again, it will retransmit the data. Is it clear? You have any doubts and confusion on this topic? I'm able to hear.